So to get the clarification, let us start the topic, and the topic is motion, whether it is existing or not existing. So to get the clarification, let us start the topic, and the topic is motion. So it is topic 2. Now, in this, the first concept, relative. What is meant by relative? So before to understand what is meant by relative, let us take some example to know actually what is relative. Suppose two friends, one is Ram and the second friend is Shyam. Both are approaching a house. This is a house. So when Ram is approaching to the house, and when you ask Ram that on which side the house is there, then Ram can say that it is towards his left side. Left. Now if you ask Shyam which direction the house exists, then Shyam says it is towards his right. Then who is correct here? According to Ram, the house is left side. According to Shyam, the house is right side. So here you couldn't decide that one is right and one is wrong, because here the house location is relative. According to Ram and according to Shyam, the two answers are correct. So location is relative. This is the first case. Now take the second example. Suppose think that we are in Hyderabad. It is morning time. Morning time. At the same moment, if somebody of your friend or relative are in New York, for him it is night time. Then who is correct here? According to Hyderabad, the morning time is correct, or according to New York, night time is correct. And the answer is both are correct, because here day and night are relative. Next, take another more example to get better understanding of this relative. The third one, I have given a stick to you. It's a stick 1, and asked you to show that the stick is shorter. Then how do you show? Then you will keep another stick which is longer than the stick 1. Then automatically the stick 1 become shorter. Now if I ask a question that, okay, show me stick 1 longer, then you keep another stick which is shorter than the stick 1. Then stick 1 become longer. So according to stick 1, stick 2, stick 1 is shorter. According to stick 1, stick 3, the stick 1 is longer. So which answer is correct? Here both are correct, because here height, or you can say length, is relative. So in nature everything is relative. So in nature everything is relative. Similarly, motion is also relative. Why it is like that? Let me explain you. Repeat. Let me explain to you. Suppose a bus is moving on the road, and in the bus there are so many passengers sitting on the seats. Consider two passengers passenger A, passenger B sitting next to each other, and there is an observer on the roadside, says O, observer. Now, according to the passenger A and passenger B, both are moving in the bus. So inside the bus, all the passengers are also moving. But according to A, passenger A, he believes that passenger B is at rest state because he's sitting next to him and he is also with him for a long time. Reaching every instant of time, he is seeing the person sitting next to him. So he believes that passenger B is at rest state. But comparing to observer O, who is standing on the roadside, if you ask him, he says that the passenger B is in motion. So according to A, passenger B is in rest. According to O, passenger B is in motion. So then who is correct? Both are correct, because motion depends upon the observer. Motion depends upon the frame of references. Motion depends upon the point of reference. So according to one observer, maybe the body is in motion, but according to other observer, the body is at rest. So in this way, motion is relative. Relative means comparable. It's a comparison between two observers. Here O is one observer and A is another observer. So I want to conclude that motion is relative, motion is not absolute. Right? I hope you understand. So next we move to the fundamentals in motion topic. To understand more about motion, we should know some technical terms in physics like distance, displacement, speed, velocity, acceleration. So first we discuss about distance and displacement. Distance versus displacement. Take an example, and we depend upon the example we're going to discuss about distance and displacement. A person is moving in this path. Start from point A, B, C, D, E and F. Say from A to B it is 7 km, kilometers. B to C it is 6 km, C to D it is 3 km, D to E it is 5 km, E to F it is 4 km. But from A to F directly, if the person goes from A to F directly, the distance is 8 km. Okay, now if I ask the person that what is the distance he traveled, according to physics, distance is total path traveled. So in this example, total path traveled means you have to take AB distance plus BC plus CD plus DE plus EF, and then it is 7 plus 6 plus 3 plus 5 plus 4. Now 7 plus 6, 13, 16, 21, 4, 25. So the total distance traveled by him is 25 kilometers, because total path you have to take into consideration. Displacement. Displacement is shortest distance between 2 points. Shortest distance between 2 points. Now here in this example, the 2 points are A and F. A is called initial point. F is called final point. So shortest distance between 2 points means initial point and final point, shortest distance, and the answer is 8 kilometers. Now if you observe the two answers, distance is 25 kilometers, displacement is 8 kilometers. That means displacement always lesser than distance. Why it is happened? Because displacement always takes the shortest distance between the points, whereas the distance takes total path traveled. So, distance is scalar, displacement is vector. Right, now I have used two new terms, scalar and vector. What are they? Now see carefully. Scalar is a physical quantity. Scalar is a physical quantity having only magnitude. Having only magnitude. Magnitude means value. In mathematics, we say number. Vector, it is also physical quantity, but having magnitude and direction. Magnitude and direction. That means when you are telling about displacement of any body or any person, you have to tell magnitude means number or value, plus you have to tell the direction too. Take an example. There is a car. This car has traveled a distance of 15 kilometers. So if I ask a question that, what is the distance traveled by the car? Then the answer is, car traveled a distance of 15 kilometers. The second question, what is the displacement traveled by the car? Then the answer is, it traveled 15 kilometers of displacements towards east. Because if you take the directions of earth, this is east, west, north, south. So you have to say that displacement equal to 15 kilometers towards east. Distance, only magnitude, 15 kilometers. So that's the difference between distance and displacement. That is also the difference between scalar and vector. So scalar is having only magnitude, means 15 kilometers, number. Vector, magnitude and direction, that means 15 kilometers towards east. Displacement is a very important concept when you are sailing in a ship and when you are flying in an aeroplane, because the pilot has to know that how much of distance he is traveling, at the same time in which direction. Because of that direction, he could know that whether he is going to the right destination or not. Now, units of distance and displacement. You can take two units, CGS and SI. In CGS, for distance or displacement, unit is same, it is centimeter. For an SI, it is meter. Generally, we use meters in all types of physics, numericals and calculations. Take one example numerical. There is a person called Mr. P moves towards east a distance of 3 kilometers, and then he turns and travels towards north a distance of 4 kilometers. Now the question is, distance traveled by Mr. P and displacement traveled by Mr. P is what? Now first come to distance. Distance, I told you, total path covered. So the total path is nothing but 3 kilometers plus 4 kilometers. 3 km plus 4 km is nothing but 7 kilometers. Over. Now displacement. Shortest distance between initial point and final point. So this initial point is A, this is B, this is C. Now the initial point is A and final point is C. So this is his displacement, AC. Now how do you find AC value? To find AC value, if you see and observe the diagram carefully, it is a right angle triangle. And when it is right angle triangle, it is a hypotenuse of the triangle, and you apply Pythagoras theorem. So Pythagoras theorem says that AC equals to square root of AB square plus BC square. So AB square is 3 square, BC square is 4 square. So it's nothing but root over 9 plus 16. So this is 5 km. Once again, see the example. Here displacement 5 km is lesser than distance. So in every case, displacement always lesser than distance. Now go for second example. A cyclist cycling in a circular path as shown here. He started from point A and is cycling in the circular path. He starts from point A and going back to point A. Let us say the radius of the circular path is 1 meter. Now consider a opposite point B. Now my question is that what is the distance traveled by the cyclist and displacement traveled by the cyclist? So again, apply the fundamental definition. Distance, total path covered. So total path covered from A to B. If you see, this A to B is the semicircle, and total path means generally path of the circle is nothing but circumference of the circle, and circumference formula is 2 pi r, and AB is semicircle, so half of the circumference, so it is pi r. And then pi value is 3.14 into r is radius 1 meter, so the answer is 3.14 meters. Now displacement, shortest distance, keep in mind A to B, shortest distance. So A to B shortest distance nothing but it is 2r, r plus r. So therefore this 2 into 1 meter is nothing but 2 meter. So with this you have to understand that displacement always lesser or equal to distance. Never be greater than distance, always lesser or equal to distance. Now my question is that, do you have any situation where displacement is 0 but distance is not? Think it's challenging for you. Now we discuss about speed and velocity. Speed versus velocity.